Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Red Team Operations with Cobalt Strike. I want to start this course by talking about the red teaming problem set. The phase of your engagement where you work to complete objectives in a target environment is post-exploitation. If you're able to do post-exploitation, this implies to me that you have positive control over something running in that target environment. Positive control, to me, means that you probably have a payload running on a compromised endpoint. This means you are successful at getting code execution. And if you were able to get code execution, this implies to me that you had an initial access strategy that worked for your target environment and context. Broadly, these are the 4 goals I see in a typical targeted attack. I fully appreciate that as a red team operator, you can deliver incredible value by focusing on post-exploitation actions alone. In this course, we will talk about each of these problem sets. And I want to take a moment to go through what you're really up against. Let's say your initial access strategy is to send an email that contains an attachment that will run your payload. So put that in there. Getting that email and attachment to your end user is not a given. First, you have to contend with any kind of mail antivirus gateway or sandboxing technologies that might dynamically open your attachment and determine if it is or isn't something malicious. You also have to contend with very aggressive anti-spam, anti-phishing filters that are designed to separate normal routine business from potential phishing attempts. And the thing about this stuff is, in some organizations, it's hard to even get a legitimate email through, let alone a phish. And so that's part of the problem set too. And then add in different kinds of standards that are certainly now more widely in use, such as SPF, DKIM, and DMARC. And things just become harder getting that content to your target in the first place. Let's say you're successful with that, and your target is motivated to open up the attachment and take the needed actions. Well, you have to worry about any kind of endpoint security products that are doing static and light dynamic analysis of your content to determine if it's something malicious. Let's say you get past that, and let's say your attachment is a Word document that drops an executable to disk and tries to run it. Well, maybe a local application whitelisting policy won't allow that. Let's say that's not a problem, and the user opens up your Word document attachment and allows your macro to run. And that macro spawns a child process like rundle32 and injects your payload into it. These two things, the spawning of a child process and the injection, are observable and in your target environment potentially observed events. And this one's a little complicated to speak to because this crosses a lot of products, but it is very common for different products to instrument an endpoint for different reasons. An antivirus product might see these actions and simply try to stop this action as it's occurring. Or you might have an EDR product that's doing the same thing. It's also possible that the event generates telemetry that is fed to a SOC and fed to a Splunk instance in a SOC that is mined through by smart, capable, and motivated analysts who are looking for signs of offense activity or compromise activity and reacting to it as necessary. These are the things that can get in the way of code execution. Let's say you get code execution. Positive control is not a given. You still need to egress the network. This means you need to contend with any kind of firewall configuration and any type of proxy. Maybe your agent is proxy aware and it's calling back to a domain that's not categorized within the vendor's proxy, and your communication just isn't allowed. Maybe you get through all of that. You still have to contend with network security monitoring. Maybe you have a user agent that's very odd for your environment, and that triggers an analyst to wonder what the source of that is. And maybe they find your child process of your Word document egressing out to the internet, and they investigate why that is. Or maybe you stood up your infrastructure a few weeks ago, and it was found and packaged into a threat intelligence feed that your customer subscribes to. And your engagement was over before it began. These are all the things that get in the way of that positive control problem set. So now you have an agent running in the target network, and yes, you have control over it. You're not done. Each action you take is a risk versus reward decision. And each action you take potentially generates an observable event that is possibly consumed by a local agent or generates telemetry that is again fed to that SOC and mined through, looking for definitive signs of compromise that trigger an investigation into what's happening on that endpoint. This course is organized around the problem set I diagrammed a moment ago. In parts 1 through 3, we will focus on the goal of positive control of an agent running in the target network. In part 1, I will discuss strategies to organize your infrastructure and your red team. In part 2, I will take you through the nitty-gritty details of configuring listeners and redirectors with the Cobalt Strike product. And in part 3, I will walk you through tradecraft considerations for command and control with the Cobalt Strike product. I will also show you how to change what Cobalt Strike traffic looks like on the wire. In part 4 and 5, we'll focus on initial access and code execution. In the weaponization lecture, I will take you through how to pair a payload with an artifact that will run it on target. In parts 6 through 9, we focus on post-exploitation and the processes and primitives in the product to help you meet your post-exploitation objectives. Here's the attack chain you will see throughout this course, very similar to what I diagrammed just a moment ago. And here's how that attack chain maps to those lectures. I want to take a moment to share some thoughts about evasion. Years ago, I would teach red team tactics, how to take different actions to meet objectives, as a separate topic from evasion. My underlying assumption then was that knowing what to do was good enough, and evasion was a skill set that was applied on an as-needed basis. Today, in a mature environment, almost any action you can take is a risk versus reward decision. And this course is now structured around that idea. Evasion is no longer a separate lecture. Instead, evasion topics are introduced with the core tactics we're discussing. So I want to say something right away that I would normally put at the beginning of an evasion lecture. Cobalt Strike is not a magic wand to defeat each defense and scenario you will encounter. That is not the product's goal. What Cobalt Strike does provide are options and flexibility. My goal in this course is to help you understand what those options are, how I anticipate that you will use those options, and to help you succeed with the Cobalt Strike product. In general, here is my advice to succeed at evasion. First, know your tools and their behaviors. Your tools, Cobalt Strike or not, will generate events. Some events are easily observable, some are not. This is an evolving area of detection engineering. But for each observable event, there are observable characteristics. Know what those are for your tool set. Know how you can change them if you need to do so. Next, assess and understand the defenses in your current target context. Different defense products observe different events and use different characteristics of those observable events to discern if something is malicious or not. Third, use your knowledge of your tools and their behaviors and your knowledge of the defenses in your current target context and decide which option makes sense. Maybe you have an option to actually avoid generating that event in the first place. Or maybe you can change some characteristic of how you execute that action so that you're still seen, you're still observed, but your action is not flagged as malicious. Or maybe you need to table that tactic altogether and use a different approach. Developing this judgment is the key to succeeding as a red team operator. If you do this and do this well, you will be an incredible asset to any blue team that uses your feedback and your perspective as a thinking and adaptive adversary to make their process and overall security approach better. So that's what I've got to say to introduce the Red Team Operations with Cobalt Strike course. Once again, here's the agenda and what we're going to go through. I hope you're excited. I very much look forward to sharing this material with you. Let's get to it. We're still in the first lecture, so it makes no sense to start this with, "Hi, this is Raphael Mudge, the creator of Cobalt Strike." You've heard it, right? You know who this is. You know what I created. So, welcome to part 1 of Red Team Operations with Cobalt Strike. This lecture is operations. Here's an overview of what we're going to go through in this lecture. I'm going to introduce you to the Cobalt Strike product and discuss major features. We'll jump into the product's collaboration model. We'll talk about distributed operations and strategies to organize your infrastructure. And finally, we'll conclude with a walkthrough of Cobalt Strike's logging and reporting features. I want to take a moment to speak to what Cobalt Strike is, what the mission of the product is, and what I see as the benefits of this body of work. Cobalt Strike is a platform for red team operations and adversary simulations. The mission of the product, consistent since day one, and day one was quite a while ago. Cobalt Strike first came on the market June 2012. The Beacon agent was introduced into Cobalt Strike in September 2012. The mission of Cobalt Strike is to close the gap between penetration testing tools and advanced threat malware. My goal all along was to push for threat representative security testing. What is the benefit of these threat representative security tests? The first one is, don't think of every red team engagement as a test. Start thinking about exercises. A threat representative security test that is either the entire attack chain or a subset of it is an opportunity for the folks doing detection and response to exercise their process and receive complete ground truth and feedback from their simulated adversary. This type of practice can very much drive maturity in an organization's ability to defend against real-world attacks. This is what I mean when I say produce battle-hardened security analysts. Another important benefit of threat representative security testing, tooling, and knowledge is to drive objective and meaningful security advances. Let me explain what I mean by this. Blue sets the stage with a defense posture and context. Red demonstrates how a thinking and adaptive adversary would work in that context. Blue uses that feedback from red to make their ideas and strategies stronger. Red looks at those changes and gives that feedback again. And this is a cycle where blue drives red, red informs blue, blue again drives red. And the outcome of this cycle, ideally, is to arrive at security ideas and strategies that work and are sustainable. This is something every security professional wants. Red teamers and other offense security professionals are very much co-collaborators in this cycle that occurs both within organizations individually and on an industry-wide scale. Another benefit of threat representative security testing is to educate security professionals and decision makers on advanced threat tactics. Advanced threat tactics are not static. They are what advanced adversaries do to meet their objectives in today's networks with today's security posture for some value of today. And as professionals with a charter to execute relevant and credible security engagements and exercises, it is on us to continue to evolve our craft and understanding of how offense is done. And as we gain new insight and new understanding in this area, It is on us to share that information with other security professionals and decision makers. The value of this is that as offense evolves, as the adversary evolves, this industry will continue to have relevant knowledge to keep pace with these advanced threat tactics. These are the reasons the Cobalt Strike product exists, and these are the outcomes I hope I have contributed to by the development of this product, and that I hope to continue to contribute to by the continued development of this product. Let's walk through some of the features in the Cobalt Strike product. Beacon is a feature we will talk a lot about in this course. Beacon is Cobalt Strike's post-exploitation payload, and Beacon has two communication strategies. It can call home low and slow and request things to do. And by low and slow, I mean it might connect to Cobalt Strike and ask for taskings once a minute, once a day, once an hour, once a week. Whatever is sufficiently slow for your context you're working in. Beacon can also be used as an interactive agent to tunnel third-party capabilities into the target network by pivoting through the Cobalt Strike Beacon agent. And we'll talk about that in part 9 of this course. Beacon can also egress a network over HTTP, HTTPS, or DNS, and it has options for peer-to-peer command and control over named pipes and TCP sockets. And it is also a very full-featured post-exploitation agent as well. Malleable C2 is a domain-specific language to give you control over the indicators in the Beacon payload. It can shape Beacon's network traffic. It can control aspects of Beacon's in-memory content, characteristics, and behavior. And it even gives you fine-grained control over Beacon's process injection behavior as well. Here's an example of a malleable C2 profile and a screenshot of HTTP traffic generated from this particular profile. Aggressor script is another important Cobalt Strike technology. Aggressor script is the scripting language built into Cobalt Strike version 3 and later. Aggressor script allows you to modify and extend the Cobalt Strike client. Specifically, you can add pop-up menus to various places in the tool. You can define new commands for the Beacon payload, and your scripts can respond to events in the tool. Scripts are also your opportunity to add new privilege escalation and lateral movement automation to Cobalt Strike. Your scripts can also change how the product generates executables and DLLs, or even uses and generates PowerShell scripts. Let's talk about Cobalt Strike's collaboration model. Cobalt Strike is very much a tool for red team collaboration. Cobalt Strike is split into a client and server component. The server component is called a team server. And the team server is where all offense action in the tool happens. It is the controller for the Beacon payload. It is the web server that hosts web drive-by attacks from the tool. And if you use Cobalt Strike to send spear phishing emails, the team server is the software component that does that. The team server is controlled by the Cobalt Strike GUI client, and multiple clients may connect to a single team server at one time. You may ask, how do I start the Cobalt Strike team server? The Cobalt Strike team server must run on a Linux system, and the Cobalt Strike Linux package includes a script called team server to start the team server. The first value you need is the default IP address or host that Cobalt Strike should propagate throughout its workflows for this team server. The second value is a shared password that your clients will use when they connect to the team server. The third value is the malleable C2 profile that you want to use. On this slide, I say it's optional. A malleable C2 profile is never optional. You always want to have a solid and thought out profile when you use the Cobalt Strike product. Do not use the default profile. To start the team server, just run the team server script from the Cobalt Strike folder. Don't forget the / and put in that IP address or host, that password, and the path to the profile. Here I am in Kali Linux, and I have Cobalt Strike installed in the root Cobalt Strike folder. Here is the contents of the Cobalt Strike Linux package, and included in that is the team server script. And here are the arguments I showed on the previous slide. One argument I didn't mention is the kill date. The kill date is a date that is embedded into your beacon payloads, and after that date is passed, the beacon payload will cease to start, and it will exit when it next wakes up and that date is passed. And this is a great tool to help clean up beacon payloads after an engagement. I would not rely on it over a good process of tracking and cleaning up artifacts, but it is certainly a good fallback. Anyways, let's go ahead and stand up this team server. I'm going to run ifconfig and find out the address of my current team server system. And we'll just do a 10.0.0.204. Put in our password, and I will specify a profile, and I'm going to use one that was pulled down from my GitHub. So we're going to go to malleable C2 profiles, normal, and I'll just use webbug.profile. If I press enter, my Cobalt Strike team server is now up and running. Here's the dialog to connect to a team server. Just put in your information, the host, the port, your elite hacker nickname, and the team server password, and press connect. Let me show you what it looks like to connect to a Cobalt Strike team server. I'm going to open up a new tab, and here I am in the Cobalt Strike folder, and I am going to run the Cobalt Strike script. This starts the Cobalt Strike graphical client. And we're going to populate the user field, and we'll just say butane, my old IRC handle. And for our password, we'll put in password, press connect, and we get prompted with the SHA-256 hash of the team server's SSL cert. This is presented to you when the team server starts up as well. And this is a chance just to verify that you are connecting to and exchanging information with your team server. Let's press yes to indicate we're comfortable with that fingerprint. And we are now connected to our Cobalt Strike team server. I want to show you the same process on a separate client system. So here we are in a Red Team Windows 7 system. I'm going to open up the Cobalt Strike Windows package and double click on the Cobalt Strike icon. Here we get the connect dialog. And let's put in the information for our team server. And I'll put in my other awesome hacker name, Rafi, and the team server password. Press connect. We get that fingerprint again. And by the way, when you click yes here, Cobalt Strike will remember that for next time. And here we are. We are now connected to our Cobalt Strike team server with a second client. I want to highlight just a few things real fast. I see three components to a red team collaboration tool. The first is session sharing. Both clients have access to any sessions on this team server. They will see the same beacon sessions and they can interact with them as they wish. The second is data sharing. Both clients have access to the data model for this team server. They can see the weblog, targets, credentials, keystrokes, screenshots, etc. The third component is real-time communication. And for Cobalt Strike, the place for real-time communication is the event log. And the event log works a lot like internet relay chat, if you're familiar with that from back in the day. You can type messages for your fellow teammates. You can use the SC command, which means show channel, to see who is in your event log. You can use /me to display an action. And you can also direct messages at your colleagues. So here I'm typing butane and tab completing it. And you also can send messages to your teammates as well. And let me show you what that looks like from the perspective of the other client. And here we can see Rafi is highlighted yellow because Rafi mentioned my handle. And here's my message I received from Rafi. So that's an example of using the event log and just a quick overview of the quote-unquote collaboration features in the Cobalt Strike product. Cobalt Strike is designed for distributed operations. The model for distributed operations in Cobalt Strike is that the client is able to connect to multiple team servers at one time. And each client may connect to the subset of team servers needed to fulfill that operator's role in the engagement. Each individual team server has a separate data model and logs and no knowledge of the other team servers. The client is always the point of coordinated actions between team servers. You may ask, why would I have distributed operations? This is to avoid a single point of failure in your engagement. If you do everything from one server, you are easy to mitigate by identifying and blocking a single host or a single set of redirectors. If you do everything with one server and the same indicators, you are easy to mitigate by finding one common indicator that unravels all of your infrastructure, all of your accesses. To connect to a second Cobalt Strike team server, go to the Cobalt Strike menu and select the New Connection item. This will bring up the Cobalt Strike Client Connect dialog. Put in your information and press Connect. When you successfully connect to another team server, a button bar will show up at the bottom of your Cobalt Strike client. Here, you may switch between active team server clients. If you want to rename a button to more easily keep track of what the server is for, right-click on the button and select Rename. If you want to close a connection, go to the Cobalt Strike menu and select Close. Let's connect to two more team servers. Here I am back in Kali Linux. I'm going to go to Cobalt Strike, New Connection. And my first team server, and it's in all my videos, is malwarec2.losenolove.com. And let me remember the password I'm using. And that was not the right one. All right, good. At least we know that part works, right? And if you can hear that shuffling, that's me flipping through my notebook to find the password that I'm using in this class, because I did write it down. Got it. The password is not password. All right, let's try that again. So let me put in my password, press connect, and voila. We are now connected to two Cobalt Strike team servers. We have our local one and our malwarec2.losenolove.com server. And if I right click, I can rename this one to local, and this one we'll call EC2, malware C2. And let's connect to a third team server. And this one will be secure.losenolove.com. Press connect. And here we are on our third team server. So this is what it looks like to connect to multiple team servers with the Cobalt Strike client. If you want to disconnect from one, go to Cobalt Strike Close. And we are now disconnected from the team server. And if we press close again, the button is gone. And you may ask, what is the benefit of being connected to multiple team servers? One of the main benefits, besides consolidating all of your clients into one interface, is that you can easily hand off accesses between team servers. And this is an important capability because let me share my thoughts on best practices for using multiple team servers. Let's say this is our target network over here. Okay? And you send your fish, you start getting your initial beaconing call out. I recommend that you have a server designed for initial access and initial access only. And I call that a staging server. This is the server that receives your initial callbacks, and it may be the server you initially operate from to escalate your privileges and spread laterally to another system. Okay? But understand this. Your first server is at very high risk of being found out and remediated. What you want to do as an offense operator is before that happens, you want to set up some type of fallback lifeline on one of these systems you compromise. And that fallback lifeline should call home very low and slow to what I call a long haul server. And this is a server with different indicators and potentially even a different tool set. But the point is that a long haul server is not where you operate. It is your lifeline to get back into the network should your access that you're working from get remediated. And again, I do recommend that you plan for the event that your staging server will get caught. And so you should have a third piece of infrastructure. And I call this your post-exploitation infrastructure. The post-exploitation infrastructure is what you operate from when you want to work to meet your post-exploitation objectives, and you request a new session for your post-ex server from one of your long-haul accesses. And the idea here, again, is that if something happens where your activity gets detected and remediated, if your separation is good enough, your long-haul access should still survive, and you have your option to continue your engagement and continue your objectives at a later time. This slide is the same information I whiteboarded a moment ago. It's a good model, and it's a good starting point for thinking about how you want to organize and separate your infrastructure. I want to share some thoughts on scaling red team operations when there are multiple target networks involved. For example, think a large cyber defense exercise with multiple blue team training audiences. I recommend that you split your red team up into target cells and a single global access management cell. The target cells are responsible for objectives in their specific target networks. They gain access, do post-exploitation, and spread laterally. They also maintain local infrastructure for these tasks. The access management cell manages long-haul accesses for all target networks. They may gain access on their own, but they also expect to receive access from target cells. Think of it as persistence or access fortification as a service. When a target cell gets kicked out of their network or needs to be let back in, the access management cell passes an access back to that target cell. It is very important that the access management cell maintains global infrastructure that is as separate as possible, indicator-wise and, of course, address redirector-wise from how the target cells are operating. The reason I recommend this model is that access management is an important job, and it is something you should devote a red team resource to. But the good news is it is a job that scales very well. An access manager can handle 1, 10, or 100 accesses nearly just as well. And so having a separate resource devoted to this task will take a lot of load off your individual target cells, but still give them the safety of knowing if something happens, they have a potential way back in. And whether you have multiple cells or you're a single red team working a single target, I do recommend that you split your team up into different roles. I recommend that you have a team member or multiple team members devoted to access. These are folks who work to get in and expand a foothold. They are thinking very much about weaponization, initial access, and even lateral movement. I recommend that you have a post-exploitation cell that is focused on the objectives you want to meet in the target network. They are the ones going through the file system, they're watching keystrokes, watching screenshots, and identifying targets of opportunity based on user activity. I also recommend that you have a local access manager. And I sometimes refer to an access manager as a shell Sherpa because their job is to herd and protect all of your shells. This is a person who manages that long-haul infrastructure and watches the health of the callbacks on it. An access manager can also be your local expert in setting up infrastructure for staging, post-exploitation, and long-haul operations. You can also delegate persistence and access fortification strategies to your local access manager. And if there is a global access management cell, the local access manager is a good person to liaison with that cell as well. Let me share a little bit about the storytelling tools baked into the product. Cobalt Strike logs everything that happens on the Cobalt Strike team server. just go to the logs folder within the folder you ran Cobalt Strike from. And the logs are organized by date and IP address of the target. The beacon logs are located in beacon_ID log, organized by the date and IP address. Your keystrokes and screenshots are also in the logs. They are under keystroke/keystrokes_beaconid.txt, and individual screenshots are in the screenshots folder under date and IP address. The beacon logs have a transcript of what happened within that beacon session. So if an operator issued a command, what they typed is shown. How the product interpreted that command is shown. Indicators that the product chose to log, such as file hashes for uploaded files, are logged. And any output received by the beacon payload is in these logs as well. And you can see that it is formatted to allow you to easily grep through these logs as well. Cobalt Strike does generate reports. Apparently you can't be a professional information security tool if you don't generate reports. Actually, all joking aside, a great deal of effort and thought did go into these reports. One of the things that's really cool about Cobalt Strike's reporting is when you're connected to multiple team servers, Cobalt Strike will merge the data from all of those team servers into one model. And it will even go so far as to synchronize the events to one clock so that you get an accurate ordering of events across these different team servers. And the capability works pretty well. In fact, at one exercise that I used to support, I once connected to 70 team servers and generated a huge master report of all the red team activity to give to individual blue teams. So to find the reports in the tool, go to the reporting menu, and there you will see all the built-in reports. Cobalt Strike can export these as PDF or Microsoft Word documents. If you want to change the logo, go to Cobalt Strike Preferences Reporting, and you can actually use a subset of aggressor script to build custom reports as well. And I recommend that you look at the documentation on aggressor script for more information on this. The first report I want to highlight is the Indicators of Compromise report. This report shows your domains and IP addresses, file hashes, and a sample of your command and control traffic. It is my intent that this report is similar to what you might find as a technical appendix in a threat intelligence narrative. Another useful report is the activity report. This report is a timeline of all the actions you took with the Cobalt Strike product on your team servers. It has the when, the where, and the what. Another interesting report is the sessions report. And I very much see the sessions report as something to augment host by host operations notes that your operators might be keeping individually. The sessions report breaks up your Cobalt Strike activity by session and target. And there you can see an individual activity summary, the communication path, and other information about each session. The last report I want to talk about that's built into the tool is the Tactics, Techniques, and Procedures report. This report summarizes your Cobalt Strike activity in the context of the MITRE ATT&CK framework. So each tactic that was used during your engagement is presented along with a timeline of related events and narrative information taken from the MITRE ATT&CK knowledge base. So you've got a summary of the tactic, mitigation options, detection methods, and a reference to the MITRE ATT&CK technique itself. So that's it. In this lecture, I introduced the Cobalt Strike tool and some of the major features. We talked about Cobalt Strike's collaboration model and its model for distributed operations and how to organize red team infrastructure. And I also took you through some of Cobalt Strike's storytelling tools, specifically the logging and reporting features. This concludes Operations, which is part 1 of Red Team Operations with Cobalt Strike.